And we would like to start the presentation now. So Dr. Anand, the floor is yours.
Okay, great, awesome. Thank you, Nick. Thanks very much for inviting us from the Goergen Institute to present here. And thanks very much to Paul and Lisa as well. So hello and welcome to everyone. Thanks for joining this session. We're very excited to share with you just highlight our data science major here at U of R, and of course in the process also share with you our our view of what we see as the exciting field of data science. So let me share my screen, and I'm assuming everyone can see my screen right now. I'll make it full screen in just a moment. Assume everyone can see my screen. I've put it on full screen right now. So great. Okay, so yeah, here we are. This is the data science module for the HeyGym Full Spectrum Seminar Series. Let me quickly introduce who else we have here from data science. So along with me, so I'm Ajay Anand. I'm the Deputy Director for the Goergen Institute for Data Science. So in this role, I lead and coordinate the education activities for the Institute. And I'm also a faculty member as part of the Institute, so I teach a couple of courses, including our data science capstone course. Along with me here is Lisa Altman. She's on the call as well, and she's the graduate program coordinator, the education program coordinator for data science. So very glad to have Lisa. And also along with us here are three of our undergraduate students. We have Anandini, Daniel, and Koa. And as we go through the presentation, you'll have a chance to hear from them as well. So they're sort of in your shoes, potentially you'll potentially be in their shoes and so it's good to hear from your peers. So let's get started. So of course we will cover sort of the highlights of our data science major in terms of the curriculum and so forth. But in terms of an overview for this seminar, we'll start with just give you a kind of high-level view of what is data science, what are the exciting happenings in the field right now. We'll also highlight sort of the career opportunities that you have with the data science major. I'm sure that there's a lot of buzz about data science, so it's good to know sort of what's out there and what you can do with a degree in this field. Then we'll kind of hone in on how data science is set up here at U of R. What are the organizations? What are the resources you have access to? So within that, we'll talk about specifically the Goergen Institute, which is serving as the focal point for data science. We'll highlight some of the research initiatives that are ongoing, and then get into more details on the education program. And then, once we get through the curriculum, we'll have a chance for Q&A and discussion. And I'll also open the stage for our undergraduate students who are actually in the class of 2021 to relay their experiences to you as well. So let's start with a high-level introduction. So what is data science? Clearly, this is probably a topic that you hear a lot about, you read a lot about. It's kind of all over in terms of new and exciting developments in technical fields. So if you were to define data science, it's essentially the application of novel techniques, typically interdisciplinary techniques, to sort of aggregate, curate, analyze, and get insights from data sets, right? So if you look at this, the Venn diagram kind of captures this in a kind of graphical form. So essentially, you have multiple fields that are coming together, and the intersection of these fields result in the field of data science. So what are those independent fields? The foundation of data science, of course, are based on mathematical and statistical methods. So maths and statistics plays a big role. You combine that with the ability to bring in computer technology, computer programming, so computer science and IT-related technologies come in. And data has no meaning unless it's tied to a domain, unless it's tied to a business context or a business problem or a research domain or a domain from a certain area. So the combination of bringing in the domain knowledge along with the statistics and math background and the computer science knowledge is what kind of defines data science. So quite frankly, to work on a data science project or to succeed in data science project involves bringing the expertise from all of these different areas. And that's what the data science training brings for you as well. So related to data science, you also hear a lot of buzz around multiple terms that are that are sometimes used interchangeably. So I'm sure many of you, all of you have heard about artificial intelligence, so AI. Related to that, we have machine learning, and more recently, we are also hearing a lot about deep learning. So the question comes up is, how do all of these kind of relate to each other? So I just have a graphic here on the left that sort of highlights that. So artificial intelligence is sort of the catch-all term. It basically refers to machines and computers being intelligent, being able to mimic the human intelligence, and kind of this is the sort of the holy grail, having complete artificial intelligence. But where we are right now is actually we are marching along in a small segment of what is called as general artificial intelligence. So the area of AI that's being practiced today is more specifically referred to as machine learning, right? So machine learning is the aspect of AI where you use statistical methods, and the whole idea is if you feed a computer large amounts of data, the computer can learn from that and then make predictions and do analysis for you. So that's machine learning. It's a subset of AI. And more recently, the field of AI, field of machine learning has evolved, and we have a new field called deep learning. So deep learning is leverages the use of neural networks. And basically, the idea is, again, if you feed in tremendous amounts of data, and this is where the concept of big data comes in, with large amounts of data, the computers are sophisticated enough to be able to make predictions and do predictive analysis. So within the context of these, data science plays the role of this whole end-to-end process. So data science more generally can be defined as the end-to-end process where we are working with data, we are collecting the data, we are evaluating the data, and we are making insights from the data. So a data science problem or a data science project would use machine learning, it would use deep learning, it would use forms of AI in order to achieve the predictive analytics components. But as a discipline by itself, data science is much broader than just AI, just ML or deep learning by itself as well. So we don't have to look too far if we were to identify examples where data science is being practiced. So I showcase a couple of here, actually 4 of them here. So if you go across this slide from top left, so I'm sure all of you are familiar with websites or tools such as Netflix, Amazon, Spotify. These are pretty commonplace now in this internet world. So when we are surfing on Netflix or on Amazon, and you've purchased some products or you're looking at some products, and what suddenly pops up is a banner saying, these are the products recommended to you, or these are the movies that are recommended to you on Netflix. So what's actually happening under the hood is these tools such as on Netflix, Amazon, and so forth are analyzing your data or your viewing habits in the case of Netflix, and trying to identify and extract what are the features, what are the attributes that define your interests, and based on that making predictions on what you would like as potential movies you would like to watch. So these fall in the realm of recommendation engines or recommendation systems, and that's clearly a data science play. If you come to the top right, we all use email. So spam detection in email is essentially an evolution or an application of machine learning, where based on the text in an email, algorithms are evaluating whether the email is a normal email or it's a spam email. The graphic on the bottom left is probably very familiar. These are the smart speakers and the smart devices like Google Home, Alexa, and so forth. So these are interpreting language and speech, so everyday spoken language, and making interpretations from that. They're leveraging large databases of information, and then coming back to you with conversational text. So this is again an application of language processing or speech recognition, and again, a big part that data science plays in. And on the bottom right, we're starting to see more of this, which is self-driving cars. So here again, as you can imagine, there's large amounts of data that's being collected, both about the car, about the environment that the car is in, and then insights or predictions are being made in terms of how the car should operate and how it should move. So again, these are real-world examples of data science, and as we see, these are becoming more and more commonplace. Okay, so let's go a little deeper and let's try to see what essentially what's involved in a data science project, or what a data science application would look like. And you can take any data science application and probably break it down into these 7 or 8 steps. And this essentially also defines the role of a data scientist or a professional working in data science. So like I actually alluded to before, every project or analysis with data starts with a problem, and typically that problem comes from the business world or from a domain that the data resides in. And so, a data scientist or a data science project could involve all or a subset of these steps. Typically, you'll start with a problem statement, you'll collect some data, you'll probably spend some time cleaning the data, making it to a point, bring it to a point that it's ready for analysis. You would do some initial exploration, and this is where you would bring in some more of the business context. You would then start to apply algorithms and techniques that are specific to that problem, and this is where you would bring in probably machine learning or deep learning algorithms and techniques. And finally, you would communicate the predictions or the analysis that you have done to the business person or the stakeholder. So it's very interesting that actually any data science problem can be mapped to these 6 or 7 steps here. And depending on someone's interest, they could be specializing in particular parts of this this workflow. What's also become very interesting in data science recently is the types of data that you're exposed to. So, many times when we think of data, we think of, spreadsheets or tables or what we refer to as structured data, so where the data is nicely arranged in rows and columns. But increasingly what we're seeing is, and where a lot of the emphasis is being on, is around unstructured data. So this is data that's, that doesn't sit in a spreadsheet, doesn't sit in a table, but it's all around us. So audio, images, video, text, and so on and so forth. A lot of the game-changing applications in data science more recently are actually in very specifically in this realm as well. Okay, so we talked about what data science is, what are the different sub areas within it, what a typical project looks like. As many of you are looking to explore data science as a degree, as a major, you're probably wondering, what can I do with that, right? So here's a slide that just captures sort of the career paths that someone with a data science degree can take. So one of the most common position that's sought after completing a data science degree is the title of data scientist. So as this Venn diagram also shows, a data scientist who specializes in different aspects of data science would be sort of a focal person in a company or organization working with data. So in that role, a data scientist would be expected to have competency in developing algorithms, which is what you learn during the degree. Also effective at communicating insights about the data, or having good conversations about the data with stakeholders. And also someone who's a data scientist would be competent in applying the latest programming technologies. So a background in computer programming and ability to translate algorithms into workable code and executable code would be sort of expected. But what we are seeing more recently is, the main title of data scientist has since evolved into more specialized titles. So you could think of data scientist as a more generic kind of all-rounded title, but you could have specializations even within that. So More recently, you see titles such as data engineer. So this is someone who's more excited or more passionate to work on the computer science side of things, so the computer programming side of things. So one of the areas that differentiate a data engineer would be that would be someone who orchestrates getting the data to a point where analysis could be done, and then on the other end, translating the analysis into productionized code, right? So being able to deploy that in a production setting and in a commercial environment. At the same time, on the other end of the spectrum, you have data analysts. So these are more people who work very closely with business stakeholders, and they also have a passion for doing storytelling with data. So they would be sort of at the front line of communicating the results from a data science project, and then working closely with the business stakeholders. And again, this is a fast and evolving field. So as we see almost every day, there are new forms that these roles are taking. Actually, there's of late you can see a combination of multiple titles also evolving. So what I show on the right here is just a subset of many of these titles that are becoming more and more commonplace. But in some form, you can take all of these titles and map it to this Venn diagram, and it would fit to some combination of what you see on the Venn diagram here. Okay, so just to give you some, in addition to give you some statistics about what the excitement around data science is. So here are some recent polls and results that have come about. So data science, of course, is talked about a lot. So data scientist is now one of the top 5 best jobs in the country. This is as per Glassdoor.com. It continues to be one of the highest paying jobs. And just as a statistic, the median salary for a data scientist is about 100K. And these are trends that are happening in conjunction with what we are seeing all around us. So what is fueling the demand for data scientists? It's really this explosion of data. So a lot of data is being generated by organizations everywhere, and also the growth and proliferation of social media, right? Social media and platforms like that are great, rich sources of data. And these are fueling the need for more and more expertise around analyzing data sets. So this is where, as a major, as a program, we come in. So the data science program at UFR is effectively helping you train in this field and seek career options in the field. So with that, let's dive into how we are set up for data science here at UFR. So in this context, I'll start with just introducing to you in more detail the Goergen Institute. So what the organization is, what the institute is and how it's set up. We'll then talk about some research that's ongoing in data science within UFR, and then we'll get into more details on the education program. So here at UFR, a lot of the data activity in data science is kind of organized and focused at the Goergen Institute for data science. We are located in Wegmans Hall, so we are right on the Hagem Quad in close proximity to the other engineering departments. Also within Wegmans Hall on the 2nd and 3rd floor, we have computer science. On the 4th floor is chemical engineering. And so, from data science, we have a very close coordination and cooperation with computer science. And as you'll see in a couple of slides, many of our classes in data science are also common with computer science. So in terms of location, we are very kind of centrally located on campus. So talking more about GIT, which is the kind of the acronym for the Goergen Institute for Data Science. The GIT Institute has a couple of different arms. So there's an emphasis around research. There's emphasis around education. There's also an emphasis around partnering with industry sponsors and the regional and national industry sponsors. And also we see ourselves as promoting data science in the broader community. So let me kind of talk to these points a little more specifically. So within research, as I'll describe in a little bit, we bring together faculty from across campus who share interests in data science, and the goal being to build on the research strengths and promote the research strengths in data science across the university. We'll talk about the education program in more detail, but just as an overview, all of the data science education programs, both the undergraduate, the graduate, and the recently launched certificate program, are housed within the Goergen Institute. And then, both to complement the research and the education initiatives, we have very strong industry partnerships through our programs as well. And from a community outreach standpoint, we organize, the Goergen Institute organizes a number of seminars throughout the semester, and these are chances for the broader community engage with faculty, students on campus as well. So as an institute, we have a core staff within the Goergen Institute of 4 of us. Lisa's on the call here. But beyond the core staff in the institute, we draw on faculty from across campus. So they come from the River campus, so the ASNE. They come from the medical school, and they also come from the Simon Business School. So if we were to look at what are the research areas that intersect data science, it's a large number. And that's where we are very fortunate to be able to draw on the expertise of faculty from across campus. So within GIDS, we have about 75 affiliated faculty. They come from all of the schools within the university, including the Eastman School of Music, the Warner School, and so forth. And sort of as a result of that, we can tap into the expertise from close to 30 departments on campus. As you can probably appreciate, data science is very interdisciplinary, so it touches on various domain areas, domain subjects. So what's listed here are the different domains from which faculty are represented. And what's unique about each of these is they work with diverse data, large amounts of data, and the application of data science techniques is what kind of draws all of them together. So in recent years, in the last year or so, drawing on the strengths of these faculty, we have organized a few research working groups. So these are basically the opportunities for faculty to come together based on their interests, based on their research interests, and sort of collaborate and identify opportunities to work together. So within this, what I'll do in the next couple of slides is I'll highlight for you a couple of research innovations that are ongoing and research trusts that are ongoing in a few of these areas. And I'll be happy to share with you additional information on how you can get more information on many of the others as well. So one of the key areas where data science plays a big role is health, as you can probably appreciate as well. And so we have a working group that's called Health Analytics and Digital Health. It draws extensively on the expertise we have here with a very prominent medical center, University of Rochester Medical Center, URMC. And so as you can imagine, in healthcare, there's a lot of data being generated, very rich sources of data. The data straddles all the way from patient data that's collected on patient information systems to wearables, so consumer wearables or wearable sensors. So this is where the Fitbits of the world come in. And also it's multimodality data. So you have images, you have audio, and so on and so forth. So as you can imagine, there's a lot of opportunity to dive into these rich sources of data and get new insights that can translate into better and improved patient care. And so we have a number of faculty members who are actively working across disciplines, collaborating with clinicians who are bringing in sort of data science into the health space. Another prominent area of thrust for us within data science university is the field of human-computer interaction. So on this slide, I'm highlighting a few projects that kind of bring the work in this area to the forefront. So on the whole idea about HCI, or human-computer interaction, is how can you effectively use data to bring out information about human interactions, or human interactions with people and so forth. So on the top left is a project where, just by evaluating images, evaluating video feeds, information is being gleaned about, what is the can we understand credibility and so forth about someone talking and presenting themselves. This also includes applications in healthcare. So on the top right, what you're seeing is an example from neurology, where, as you can imagine, in the current world, this is becoming more prominent, where a lot of things are being done remotely. So this is an application in Parkinson's disease, where a clinician could be evaluating video feeds, or evaluating a patient on a screen, but in the background, an AI or machine learning algorithm could be evaluating that as well, and providing additional feedback to the clinician in terms of observations made on the patient. There have been a couple of other applications as well that are focused on different aspects of this. So on the bottom left is an application where, just based on a user speaking into a camera and the video being evaluated, you can give some feedback on how the presenter is presenting themselves. So as you can imagine, this has actually been an application that has been used in a variety of public speaking training and opportunities of that nature. And then on the bottom right, this is an example where, just again, by evaluating multimodal data, so evaluating video, evaluating audio, the level of humor in a paragraph or in a video presentation is being very automatically being evaluated. So here at the UFR, we also are fortunate. We have a leading music school in the Eastman School of Music. So we have a number of faculty members who have been collaborating across departments, across schools. This slide actually showcases a few examples where collaborations in the field of music and data science have taken place. So the top left basically shows the ability for sophisticated machine learning models, or AI-based models, to actually generate music. So the way these work is, the computer is able to glean across many data sets, or many audio samples or music samples, and then interpret the style of a certain composer or a musician, and then generate music based on that information. So as you can imagine, that greatly helps kind of enhance the ability of a few human few human artists to embrace the use of computers to enhance their the music impact, or the music effect. Also, there's been quite some work on interpreting artists and then the performance of artists in a music performance. That's in the field of audiovisual sensing. And then on the right here, what's shown here is basically, everyone today, we use Google search. And as you can imagine, Google search operates by performing a text-based search. So the idea here is, can we perform a search based on the user providing a sound sample and asking the computer to bring back, to output additional sound samples that are similar to the one that the user just provided. So this is an area where you can do sound search purely by vocal imitation. So the user is basically providing a sample, is speaking, or it's singing, and then the computer spits back related samples that are well correlated with that user request. Also, there have been quite some work done by faculty around generative models. So these are where you have some pictures, and the computer is able to morph those pictures into new renderings of the same to provide different effects. And that's what you see on the bottom left here. Also, at UFR, we have very strong expertise at the intersection of robotics and data science. So we have a few faculty members who are working on robotics and AI-based projects. And these straddle, again, a couple of different areas. So the one on the left here is about can we bring in language understanding along with the field of robotics. As you can imagine, robotics plays a key role in healthcare as well. And again, these are all areas where tremendous amounts of data is being generated. On the right here is an example where sensors are being used to measure the electrical activity in the brain. As you could imagine, this generates large amounts of data, large volumes of data, and the ability to correlate the information that you get from these electrical signals with physical activities is a major area of research as well. So with that, I will switch gears now. I gave you a kind of an overview of the research activities in data science, which actually many students also are very actively involved during their time here at UFR. Now I will kind of dive deeper into the major itself and what the curriculum would involve. So as a data science major, as you progress through our curriculum, you'll be taking a number of courses. And these courses are primarily designed to bring you up to speed on the competency in the areas that define data science. So if you recall my first slide, data science, as I presented, was at the intersection of math and statistics, programming, and also the domain areas. So essentially, our curriculum reflects that. So as you go through the curriculum, you'll be taking courses at the intersection of all of these three areas. So as part of our prerequisites, we require you to build up on the calculus and the math courses. Along with that, we have a couple of courses that are around the CS prereqs, the computer science prereqs, to bring you up to speed on the programming background. Following that, you have core courses that involve both math. They involve computer science courses, and then also we have statistics courses as well. Following that, you have an opportunity to actually specialize in one of multiple application areas. So again, this is motivated by the fact that data science has a role in many different domains. So this is a chance to build up some expertise in how data science is being practiced in a certain domain. And this could be, an area that you're naturally interested in, and you want to bring data science together with that area of interest. Beyond the traditional coursework that we have, that we will cover, you also have the opportunity to participate in a capstone project. So this is actually a core course in the curriculum. And I'll talk about the capstone course in just a moment, but this is an opportunity actually to draw on the learnings from the more traditional courses and then apply that in a sort of real world setting to address a real world data science problem.
AJ, just real quickly, that application area that you list there, are those sort of the recognized ones, or are other areas possible as well?
So these are the ones that are approved currently in our curriculum, but on an ongoing basis, we work closely with departments to identify new areas, and then of course they have to be formally approved, and then they can be offered as part of the program. Yeah, thanks, Paul. Yeah, thanks for clarifying that. Yes, so what I just showed is the core, sort of the typical structure for our BA/BS program. You have the opportunity to earn a BA degree or the BS degree in data science through this program. If you do choose the BS degree, there are a couple of supplementary courses that you have to take, and these basically are from the math. So you have the introduction to probability, introduction to mathematical statistics, and in addition, we require you to take an advanced elective. This, as you can see from this list, this also draws on the sort of the higher level computer science courses. Between the BA and BS, we have a sort of a 3/4, 1/4 split. So most of our students are pursuing the BS degree, a quarter or so are pursuing the BA degree, and many times they're pursuing double majors as well, and I have a slide on that coming up as well. In addition to the sort of the core technical requirements, there are additional requirements that are, for the most part, common with other majors at UFR. Of particular interest to note is that data science is a natural science major. So this is where it's a little different from engineering. But as a result, we require you to, in terms of cluster requirements, we require you to do a humanities cluster and the social science cluster. In addition to the clusters, there's the upper level writing requirement, one of which can be satisfied by the data science capstone. And the other is either a formal writing course or some other upper level writing. Coming to the capstone, this is what I alluded to before. This is typically a course you would take in the final year, in the senior year. And the whole idea here is, as part of the from the program, we have students work in teams, typically teams of 3 or 4, and we will partner the teams with regional organizations, local and regional organizations. So the whole idea is the students working these teams will execute a real-world analytics project, a data science project, and the project statement and the mentorship comes from the sponsoring organization. And the whole motivation here is to give you a feel for what real-world data science problems look like, and also emphasize a team-based learning experience. So off late, in the recent years, we've been fortunate to have the opportunity to work with a large number of companies, sponsors. These organizations range from industry, the government, and also non-for-profits. On the right here, you just see a snapshot of some of our recent sponsors, many well-recognized names from the Rochester area. In recent months, we have also been fortunate to work with some Silicon Valley companies, and also some government organizations and non-for-profits as well. So I mentioned earlier, we have students pursuing our BA, our BS program, but also we have a number of students who pursue double majors. So this is an opportunity where you can actually combine 2 majors, and our data science curriculum is well set up to facilitate that. And what you're seeing here is just a snapshot of some of the common majors that students have pursued. Again, you have to be cognizant of the overlap requirements, but these are managed at a college level at the UFR. So as a student in the data science program, you also have the ability, and we actually encourage this very much, to actually work closely with research groups, work with faculty, participate in research projects, and you have a couple of different ways or mechanisms in order to do that. So something very organic is, you work, you get to know a faculty member, you really, you're excited about the area of research, you participate in their lab's research activity. You could more formally do that through an independent study, and this also gives you credit for that research that you're pursuing. Also during the summer, there are opportunities at a more, both at the university level, but also more nationally, where you can participate at a summer REU. These are actually federally funded programs by the NSF, and these are specifically designed for undergraduate students to participate in research. And off late, as you can expect, there are a number of opportunities that involve data science research. We also have a pretty active study abroad program. Many of our students have pursued this. And you can do this as a declared sophomore, as a junior, or a first semester senior. What the names of this university listed here is just a small sampling. We have had students quite extensively pursue these opportunities more broadly beyond these universities listed here as well. Also, integral to the curriculum is what happens even beyond the classroom. So we actively encourage students to, participate in other activities that student groups offer on campus, with focus on data science, and also what the Goergen Institute offers in terms of seminars, workshops, and so forth. What's shown on this slide is just a sampling of various activities that, to a large extent, many of these are actually student-driven. So we have an active undergraduate data science council. We have been an active participant in the Grace Hopper conference from the Goergen Institute. Typically every year there's a small group of students who are participating in this yearly event. We also encourage participation in organizations like the Dandy Hacks, which organizes hackathons and so forth. And also many of our data science students are active in larger campus-wide societies and groups as well. So finally, I'm sure you're curious, where do our graduates land up after they graduate from our program? So here's a listing of, let me make sure you can see the bottom of the slide. So here's a listing of where our recent graduates have ended up in terms of their career choices. So this is a slide that shows the different roles they have taken on in industry specifically, and you can see it's a sampling of a wide range of industries. It's all the way from the large tech companies to companies in various other domain areas as well. Many of our graduates from the program, from the undergraduate data science program, also decide to pursue graduate school. So we have had students pursue graduate school opportunities in a variety of related disciplines. Some of them choose to stay within data science, some pivot in related areas in computer science, or possibly even in fields that are STEM related, but also in business related fields as well. So we talked a lot about the undergraduate program, but we also have a master's of MS program in data science, which can be completed in a relatively short amount of time following the bachelor's degree. And STEM graduates who have STEM degrees, including engineering and or CS degrees or CS minors, make great candidates to the data science graduate program as well. So just a small plug for our graduate program as well. So with that, I actually have concluded the formal part of the presentation. I would like to now open it up to give you all a chance to hear from really your peers. So we have three of our undergraduate students here. We have Koa, Danielle, and Anandini. So what I would like is, I would like each of them to jump in and probably reflect on their experience here in the data science program and tell just describe their thoughts a little bit. So let's start with Koa. So Koa, if you want to kick this off, please do so.
Sure. My name is Koa. I'm a senior, majored in microbiology and data science. So my route into data science is not, I think, is not as standard as many other students. I first started with microbiology and decided to go to data science quite late, around my second semester of sophomore year. The reason is that I want to study a little bit of data science so that I can apply it into biology, because in biology now it has so many data, from DNA sequencing to proteomic data to image data. So I want to have some skills in data science that I can apply to biology. And it has helped me a lot, actually. Like this, for example, the COVID-19 happened and all of the labs or something in biology had to close. So I started participated in some of the data science projects in bioinformatics or developing software for image analysis. And recently I've been working on some data analysis of flow cytometry data, which is very high dimensional and require a lot of skills that I learned in the data science courses. So I definitely think that my decision to go into data science is one of the best decisions that I have made in college, and really encourage everyone else to take a shot, take some courses in data science and give it a try. And even if you are not a data science focused major at beginning, for example, like me, you can still shift gear and take some courses and catch up, and that's completely fine, and you will you will definitely do very great in data science courses.
Great, thank you, Koa. Danielle?
Hey everyone, I'm Daniel He. I'm from Redmond, Washington, and I'm a double major in data science and economics. So in freshman year, I started out as a computer science major. After my parents, who are also in the CS industry, kind of convinced me to do it, but I eventually switched to data science in my sophomore year. I want to go into detail about the reasons why I switched and some of the differences between the two, even though they're perceived as really similar or the same. So I found computer science to be much more technical than data science because you have to understand how the computer works, the software and hardware. And so since the language of computers is programming is like a core aspect of computer science. And I felt that it kind of lacked my creativity because it's just a lot of projects and doing code a lot. So when I found data science, it's more of a new field. Since computer science is growing too, there's a lot of data that comes with it. And I found data science to be more about problem solving and using data as this tool. Well, of course, the data science still requires programming as a tool to achieve its goals. It's more allows creativity in problem solving. And I like that more. So some of my favorite projects involves my own Spotify recommendation system. And I started this because I wanted to find new songs for my playlists. And so I used a data set I found online that describes Spotify songs and their characteristics. And I used machine learning to generate some new songs in that data set that I prefer. I thought that's pretty cool because it solved a problem. I started with a problem and I solved it. So I think the two major parts of CS is you have to have an engineering mindset and you like to program. And for data science, the two are having an analytical mindset and problem-solving mindset. So my advice to anyone is to, even if you're doing CS or data science, is to challenge yourself with projects, because the best way to learn is to actually struggle. And that's where you actually learn the most. And my plans for after graduation is going to industry, looking for either data engineer or data science jobs.
Great. Thank you, Daniel. I appreciate that very much. And Anandini.
Hello, everyone. I'm Anandini, and I'm also a senior. I'm a double major in data science along with economics. And I began my sort of college career interested in pursuing economics alone, but then decided to tack on data science as well because I really enjoy mathematics, especially probability. And I wanted to learn more about programming and generally understand how algorithms are written and get good at coding. And also, I think at the time when I was beginning college, there was a lot of buzz around sort of data analytics, data science, and also like understanding things about artificial intelligence and machine learning. And I think the major sort of really helped me in developing an understanding within those areas and gain exposure to them and actually understand the different algorithms that are used in these different fields and write my own programs. I thought that was wonderful. I think one of the most sort of gratifying aspects of this major is that you can write an algorithm, you can design a program, and then you can see the output right before your eyes. And that is probably my favorite aspect of the major. So I quite agree with Daniel when he says that you have to be sort of uncomfortable to be able to learn the most because it is quite challenging. You have to develop a problem-solving sort of mindset, and you have to develop core mathematical skills, which are going to assist you in writing the most creative or the most efficient solutions and programs for your whatever it is that you're trying to achieve. So yeah, and I think the majors really helped me in developing programming skills in something like Python, which is very widely used nowadays in different fields, whether it's sort of gaining familiarity with using different libraries that are commonly used, and also kind of understanding more about machine learning and artificial intelligence. So this summer, I actually participated in a virtual internship, which was specifically in the area of machine learning and natural language processing. And I thought that my major sort of really enabled me to develop the skills that ultimately helped me during my internship. Yeah, and going forward, I also want to work in the industry as a software engineer.
Okay, great. Thank you, Anthony. Thanks to all of you, Koa, Daniel, and Anthony, for sharing that. I really appreciate it very much. So I think that, yeah, that essentially wraps up the sort of the slide deck and the planned part of the presentation. Happy to open up for questions and discussion. Just a note here, if anyone is interested in more information about the program or questions, please note this email address here. That's our kind of touch point for any question related to the undergraduate program. And also, please feel free to follow us on LinkedIn or Twitter. We post a lot of updates about recent happenings in data science around the university, our program, and also information about upcoming talks and seminars and so forth. So great, thank you all. But definitely happy to open up for questions and discussion right now.
We have one of the questions in the chat. It says, I am really excited to opt for data science as one of my majors, but is it possible to graduate on time with double majors, one of them being data science?
Yes, so yeah, Ahmed, yeah, that's a great question. It's definitely possible, and we have students. We have many majors who are, doing that. The advice to you would be, just to have that planned as early as possible. So you have time to accommodate the requirements you have in both of the majors and make sure that you can complete that on time. The main thing also to watch out there for is, and again, it's part of the planning process, is understanding how the overlaps can be used effectively, and also making sure that from a schedule standpoint, you plan your courses such that you can achieve that, you can meet the requirement for both and graduate on time. But we have good examples of many students who have successfully done that.
All right, the next question is, how is data science used in economics?
Okay, yes, Michelle, that's a great question. A big part of economics is modeling. So, in modeling, in economics, just as an example, you're looking at number of economic indicators or economic data, and you're trying to build models that reflect how that data will change over time. And so a lot of the techniques that are used in economic modeling, they originate based on, looking at properties of the data or looking at the features of the data. So while traditionally a number of statistical methods have been used to do this, more recently you see kind of this intersection of statistics with more formal like data science techniques in machine learning, deep learning, and so forth. So for example, in one of the slides I just mentioned about like neural networks or deep learning, those are more and more increasingly being used with financial data and economic data. So that's a great example where the traditional techniques in statistics continue to be used, but they're being either supplemented or enhanced with additional methods from more modern machine learning methods.
I have a question for the students. With advising, we talk a lot about ideas and then putting them into practice. For the students who didn't start out as data science, can you talk about the process from when this came to be an idea into actually switching to data science and how long that took? I think a lot of the prospective students would be interested in knowing.
Yeah, sure. So I actually started in my second semester of sophomore year, so it takes quite a while for me to decide it. I always enjoy coding and programming, but I never think of like like having a major in that. But um, because I see the trend in other fields, like whatever that is, right? For me, that is biology. Um, that nowadays it becomes more and more an informatics science. It has so many data that it seems to me like if I study this field and I don't have that data skills, it seems like I I lose a very huge aspect or potential that I can do in my field. So with that thought, I decided, okay, I have to take this major. Yeah.
I want to add that I was following a lot of these data science applications in the news, especially with deep learning. That got me interested because data science is a pretty new field. It's important to just follow the news, what's going on in research.
Mhm.
For me, it was fairly early, I would say, in the sense that it was kind of there in the back of my mind that this is a possibility worth pursuing. So I started, I think, spring semester of freshman year with my first computer science class. And I was still a little bit iffy, but I wanted to definitely give it a serious shot. Yeah, and it is a bit of a challenge, especially if you've never done computer science or never sort of taken any programming classes in high school before, because it is a bit of a learning curve. But yeah.
Right. What other questions do we have? Any other questions?
Let me quickly ask, and this may not be correct, AJ, but my impression of data science is that it initially grew out of these enormous data sets and then wondering what to do with them. I'm wondering if in the future data science will have more about figuring out how to collect the data so it doesn't have to be cleaned, or how is that part of a data science now? Is that coming in or not?
Yeah. Actually, Paul, you bring up a very, very important point. So let me go back to a slide I had here, which is that the flow, the workflow. So yes. So a lot of the excitement we saw about data science was as people were having these large data sets. How do I bring insight? How do I develop insights from this data sets? How do I use this data effectively to make decisions and so forth? So that's where the modeling, the predictive modeling, the visualization, these come in. But as people are doing that, they realize that the real world data that you work with is not always clean. It's messy. It's coming from the real world, and a lot of effort actually has to go into it to bring it to a form where it's ready for analysis. So there's actually a saying that says on this flow here, actually 80% of the work or the effort is actually spent in these first few steps in order to get the data in a form and in a manner that lends itself for analysis. So as we go along, I think as people are working with figuring out how to effectively manage large data sets, there are also there's a lot of emphasis on how do I ensure that it's reproducible, it's in a form that can be readily leveraged for analysis and gaining those insights.
There's another question. How much time does it take to adjust to majoring in data science, considering one just knows introduction to some programming language, but it is strong in mathematics aspect of data science?
Yeah, so this is where, again, I think it was Koa and Daniel who also mentioned a lot of the skills that you build in data science also comes from working on projects. So I definitely encourage students who are pursuing data science, through the courses to take all the opportunities available to to get their hands dirty and feet wet with working on real world projects and so working with data sets and projects. But specifically, the answer to the question of how do you build up the competency around programming? As part of the curriculum, we want everyone to take the introductory programming courses, but we also have specific courses that are more covering the breadth of different programming technologies you will need in data science. So a course that I will mention is what we call Tools for Data Science. So Tools for Data Science is DSC 201, which actually is a semester-long course that exposes students to all the different programming tools and methodologies that are used in data science. So with a course like that, it helps you kind of get up to speed, and then kind of helps bring everyone to the same playing field when they're then taking some of the more advanced courses in data science. So that's one kind of more formal avenue, but a more kind of more practical approach is also to participate in projects and sort of build the competencies that way as well. And I believe there was there a question before this about high school?
Yes.
Linear algebra, right?
It's about linear algebra. A student is taking linear algebra now, and they want to know if they can test out.
Yes. So typically, to transfer over a course or waive out a requirement, we have a process where you can basically submit a request, and we have it validated by the corresponding faculty member or the department that is offering that course here at UFR, and that is how we make the determination that we can give you credit for the course you've taken before you join the UFR or before you take the course at UFR. And Nick, if you want to add to that from an advising standpoint.
Yeah, I mean, it's one of the things we talk about a lot in advising is in high school, there are a lot of can I questions. Am I permitted to do this? Am I permitted to take advanced placement courses? In college, most of your questions are should I do this? So whereas you might be able to get advanced placement credit, or you may be able to take a course and transfer it in, sometimes you might be better off in taking that course again, just to make sure that you have the background. The best part is that you have a lot of time to determine this from the time that which you're accepted until you actually set foot in the classroom or take it online. So yes, you would potentially have the opportunity to do this, but we would decide with your advisors if this is the right thing that you to do, or if you would benefit from being able to forfeit credit in the opportunity to learn more about the subject and also potentially to get an A.
I would also mention typically you can't get college credit if the course is taught at your high school. We normally don't grant the formal credit for that. So you might come in with the knowledge, but typically we don't grant the college credit for a course which is taught at the high school. So if you're taking it in high school at the college, that would work, but the other way around is a problem.
I can add to say the most common courses that people might get exempt from because they did AP courses in high school probably would be a calculus course, maybe both calculus courses, sometimes a computer science course, maybe a statistics course. So those are probably some of the most relevant AP courses that do find its way in the data science major.
Do you have any more questions? All right. Well, thank you, Dr. Anand and the students, and Lisa for coming in to talk about data science. The good part about this is it does field questions for students who are watching this asynchronously. Oh, we have one more question. What is the average class size?
I'll answer that. This is a new department, so we've been growing and growing year after year. A few years ago, it was maybe 12, 20. Now our classes are growing, and we have 50 or 60 students who will be graduating this year in data science. We don't know if that's going to continue to go up, but it's definitely, now that many of the students who have started, you know, the students that are here today, this program was available to them as first-year students. And so now that it's more established, we have quite a number of students who know about it now.
Any last questions? All right. Is GIDS independent entity from any department in UR?
So yes, so GIDS is an independent entity. You know, we are not an academic department by definition, but you know, from a student perspective, you know, you have access to all of the faculty who are affiliated with the institute, and through the courses that you'll be taking, you know, you'll have access to, you know, you'll be interacting with faculty who are from various departments at UFR.
Yeah, just in other words, yes, but as a student, it's probably irrelevant.
Yeah, it doesn't have any bearing.
As a faculty member, it affects you, but as a student, it probably doesn't affect you at all.
When I apply, do I pick data science as a major? So so formally you declare, yes, you can express data science as your major when you apply, but you have the opportunity to actually declare data science as a major all the way until sort of the sophomore year, the spring of sophomore year. So you know, we have students who defer making that choice of picking data science as the major, but we encourage you to do it as early as possible so you can manage the courses accordingly. But it can be done even after you've started at your UFR.
Unlike some other schools, UR does not admit you into a particular college or program. You're admitted into the university. So, you know, moving between engineering and data science, or data science and physics or something is much, there isn't a separate application process and all that. It's very straightforward.
Any other questions that we have? All right then. Well, if there are no more questions, thank you again for doing this. We hope that this is just the start of the conversation. I think that we have so many of the students that I work with that switch to data science are very satisfied, not only with their choice, but they feel there's the opportunity to have opportunity to advance, and especially go into industry and to go on to graduate school. So it is exciting. This is an untapped resource for some cases. And so that's what a lot of the students say, that this is the next thing that people are going to be doing. So it's nice to be in this now. So again, we thank you very much for doing this. Like I said, we will post this for students who are viewing this asynchronously. We're also going to post contact information so that you can ask your questions and get more information in the future. Like I said, thank you again, and that'll do it for today, and we hope to see you all soon.
Great. Thank you, Nick. Thanks, Paul. Appreciate the opportunity. Thanks.
Thank you, AJ. Thank you, everyone.
Thanks.